Section 1.2, Accuracy and Precision. Today we're going to look at accuracy and precision. First we're going to look at the definitions of the words and what they mean, and then we will look at how it applies to science and why we care. So first, accuracy is how close a measurement is to the correct or accepted value. And precision is how exactly a measurement is made. So what does that really mean? Okay, you might be wondering what in the world those means. Right now they're just a bunch of words. So let's take a look at accuracy again. So when we say accuracy is how close a measurement is to the correct or accepted value, we're going to look at an everyday example first. So if you're going to take a test, you might have a goal of getting 80% on that test, okay? So that would be our accepted value in this case, because that's our goal, that's what we're aiming for, that's our target. If you take that test, and instead of getting 80%, maybe you get 79%, okay? That's pretty good accuracy, okay? Because you're really close to our accepted value. If instead, say you got 63%, ooh, what a scary number, right? We might be a little sad about that if we're getting a D. Okay, that is not very accurate because it is not close to our accepted value. Okay, so close equals accurate, and not close equals not accurate. Now let's precision. Precision is how exactly a measurement is made, and we can say that a couple different ways when we say exactly. We could say how closely, or we could say how similarly. And now let's look at exactly what I mean by that. So we have the same test where our goal was 80%. Okay. But now we've taken 3 tests. Maybe it happens over several weeks. Maybe this is a class. And your goal was 80% for the class. So on the first test, you get 73%. On the second test, you get 75%. And on the third test, you get 77%. Okay. So these are all pretty close. They have a very small range. They're all within 2 points of each other, right? These are within 2 and these are within 2. So they're all very closely related. They're similar, okay? So in this case, even though you didn't reach your goal of 80%, you do have similar scores across the board here. So you have a very precise ability to take these tests. Now let's look at another example. This example you commonly find in textbooks. And when we look at it here, we have this bow and arrow situation where you're aiming for a target, okay? And on this one, as you might guess from this little A, I'm not sure what happened to those words, okay? But this one is accurate because all 3 bows hit the center of the target. So this one we can say is accurate. Another way of saying this, if we wanted a synonym for accurate, would be it is correct. They are correctly hitting the center of the target. On the other side here, we have a case where they're being precise. Okay, all 3 arrows are close together, and only one of them is in the target. Okay, so we wouldn't say that it's accurate, but it is precise. So we can write precise here. And with that, another synonym for precise is consistent. So they're consistently doing the same thing. They're able to hit the same spot. So looking at the pictures in another way, you can have an accurate and precise situation like we have here. You can have precise but not accurate. And if you were to shoot these arrows and they end up all over the place, so not hitting one spot, not hitting the target, they're just everywhere, then it is not accurate and it is not precise. So let's take a look here and see if we can figure out, by looking at this data, what is accurate and what is precise. So these 3 groups may have been students just like you. And they were doing an example where they needed to find the acceleration due to gravity. Okay, so the accepted value of the acceleration of gravity is 9.81 meters per second squared. And this experiment has been done thousands, if not millions of times. So that's a very sure number, okay? So let's look at group A. Group A, all their values are close together, okay? 8.45, 8.37, 8.61. They're all closely related, but they aren't really near 9.81. So we'd say that group A here is precise, but not accurate. Now group B, their values are all over the place. They have 10.2, 9.73, which is actually close, but then they've got 11.43, which is way off. So this one is both not precise and not accurate. Now, the last group we have here, they have values of 9.85, 9.77, 9.81. Those are all very closely grouped together, and it's very close to our accepted value. So this set of data would be both accurate and precise. So obviously when you guys do your experiment, I hope that everyone can end up in group C where it's both accurate and precise. But that won't always be an option just because of the tools we have to use. Why we care about accuracy and precision a little more. We care about accuracy and precision because it helps us understand potential errors in our experiments. And we care because we want to minimize errors so that our experiments are accurate and precise as possible. And this specifically gives us the ability that if we have less error, it allows us to analyze and conclude more effectively. So if our data is sloppy, if we have data all over the place, we don't know whether the data that we have is good. We don't know if it's bad. We're going to guess that it's bad because it's not precise. But it doesn't tell us any information. We can't compare it to accepted values to find out if we were right or if we were wrong. Now we can also look at things this way. Okay, I'm going to move this up a little so we can see it. The tools we use determine the accuracy of our measurements. So if we think about the example, group A, they had 8.3, 8.4, 8.6. They were very precise. Probably there was a tool or some sort of systematic or regular error in their experiment that kept them from being accurate. Maybe if they used a stopwatch, they hit it a second later than when they actually dropped the ball, or something like that. Okay? But with that then, for precision, how carefully we take our measurements is what determines our precision. So we can always be precise no matter what tools we have as long as we are doing our experiment carefully. All right, I hope you guys understand a little bit more about accuracy and precision, and please let me know if you have any questions. Thank you.